Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to be modeling a TE37 style rim in Plasticity. Now, I get a lot of comments, emails, questions about using Plasticity with precise inputs. So if you're trying to 3D print or if you're trying to manufacture parts, that's obviously a critical step in the process is to understand how we can do that. And we don't have a traditional sketching environment and we don't have parametric history like we do in other CAD programs, but it still can be done in Plasticity. So we're going to talk about ways that we can have precise inputs, some of the shortcut keys and things that we want to make sure that we understand and so on. Before we get started, it's also important to remember that we are a Plasticity affiliate. If you are looking to purchase an Indie or a Studio license, use the code LEAD10 at checkout, and that'll get you 10% off of your purchase, and it does help out the channel. This video is not for absolute beginners. So if you've never opened Plasticity before, then you probably are going to have trouble following along. I will still call out all the shortcut keys and everything that we're going to be doing, but I'm not going to go over the UI, how to navigate, and those sorts of things. So if you're struggling with getting started, make sure you do check out our quick start guide that goes over the UI and UX a bit more, and that would be a good place to start before hopping into something like this. So the first step for me is to start a new design. And once we start a new design, we're going to double check our units. So inside of our preferences, I'm going to use the inch unit system because most rims are set up in inches. And we're going to talk about inch and metric conversions in the dialog boxes for those dimensions as we go. So if you want to use millimeters, you certainly can, but just keep in mind that we are going to be using inches. The grid size honestly doesn't matter to me. I don't ever snap to grid. You can if you want to. For me, it's just I don't enjoy going that way. But if you want to, you can always snap to grid and turn it on and actually change those the increments of the grid here as well. So to get started, delete. If you don't know what a TE37 rim is, then you can just do a quick Google search. There are so many variations of this rim, and there are going to be geometry differences depending on whether or not it's forged, depending on the backspacing or offset of the rim. So you're going to find all kinds of images. If you want to use an image inside of Plasticity, you want to use the import append option, and you'll go into wherever you have an image saved. So here's an image of a TE37, and we can see that it brings it in. Now, the problem here is we don't know the scale. So before I get started, I generally will go to my circle tool, and from the origin, I'm going to hit tab to go over to my dimensions and put 18. We're going to create an 18-inch rim. So now when we zoom in, we can see that the image is quite a bit smaller. So we're going to hit S twice. So if we scale once, or if we hit S once, we can scale in plane by using this little box gizmo here. But if you hit S again, then all you need to do is move the cursor. So it's a little bit quicker, especially if you're used to Blender, than just hitting S twice. Also note that the bolt circle, this image here is a 4 lug. We're going to be doing a 5 lug. It could be whatever you want. You can make it 6 lug, doesn't matter. But it's also a good idea to just do a quick reference check. So tab on the keyboard to our dimensions again, 4.5 inches for the bolt circle. Now that is a 114.3 millimeter, pretty common size. And we can see that we're a little bit off. The image is not perfectly centered. The bolt circle reference is not perfectly in the center of each of these lugs, but for what we're doing, it's close enough. Again, you don't need to have an image to do this, but if you want to understand how to use an image, then this is kind of that step. The next thing I want to do is put a 5.75 inch circle here. That is going to be a reference for where it dips in. So most of the TE37s are going to have a sort of sunken in, rounded, recessed center section. And knowing where that transition is kind of important because it dictates how we're going to build the spokes. You also note that a lot of these spokes are tapered, and that's something that we can do. We can handle that taper if we want. For our example, we're going to keep it straight, but the basic process of doing this will be the same. Another thing is if you use images, you can hit M on the keyboard, which will bring up materials, and toggle on opacity so you can kind of see through it. Once you have solid geometry, that's going to be a pretty nice feature. So we're going to hide this. The outside diameter I don't really need. It was only there for scale, so I'm going to delete it. The inside diameter for the bolt circle I don't need because we're going to take care of that later. This one here, it's good to understand what the dimension is. And we can do that by going to our Find tools. So hit F, which will bring up the search dialog box, and put Measure. This is Control plus equal if you're on a Windows machine. And we can see that we're measuring roughly, it says 5.6 here. Obviously, we typed in 5.75. When you use measure on a circle like this, it's kind of tricky because it'll go based on that center point. But it's a good sort of quick reference to just double check that we're in the right scale. And I don't need this circle, and we're just going to get rid of it. So all that work was really just to get the image in, to get it scaled, and have some rough idea what these dimensions are going to be. For a part like a car rim, what we're going to be doing is drawing profiles that can be revolved. So this is going to happen from a side view. So 3 on the numpad will take us to a right view. And then I'm going to start by creating a vertical line from the origin, hit tab, and I'm going to enter 9. So this is a radius value because we're dealing with only half of the rim profile. We're going to go up 9 inches, and that'll give us our essentially 18-inch rim. Then I'm going to do a horizontal line. I'm going to hit tab, and we're going to make this rim 8 inches wide. You can make it as wide as you want. You can put the back spacing wherever you want. But now we've got a reference for the diameter, or the radius really, and then a reference for the width. Now that I have this line and it's currently selected, I'm going to use the Move tool, and I'm going to move it in the Y direction. So hit Y, and -3 inches, and hit Enter twice. Now the reason for this is because now I've got a center reference, and I've got a front and back reference for the rim. So we're building out that profile. Now, if you want a deeper dish rim, then you would move the line further forward, and that's going to change the way that you build out the spokes. At this stage, I don't really need this vertical line anymore. It's selected, so I'm going to hit H to hide it. I might come back and I might decide to use it. But for right now, the only thing I care about at this stage is going to be building out my rim profile. So this is going to start with some lines. And there are a couple things that I want to cover here. And these are some of the questions that I get. So at first, when we start and we start to drag up, if I hit tab, I of course go to the dimension, I hit 0.5, and I hit enter, it's automatically going to accept it. Now this is something that changed when we went to version 24.1.1. So the plasticity version numbers are going to be based on the year. So they're all going to start with 24 this year, and it might be 0.1, 0.2, it might go to 0.2, 0.1, and so on. But anyways, it's starting with 24, and that change or that shift from the first release of Plasticity marks the fact that we only hit enter once or right-click once to accept or confirm. Now the problem with that is if you're used to doing it the old way, you're oftentimes going to get outside of those dimensions quickly, and you're going to have to go back and make some manual changes. So we're going to talk about how to manually change this line. I need it tilted forward, let's say 5 degrees. So we're going to use our rotate tool. We're going to change our pivot point by saying V on the keyboard and just snapping it there. And then we're going to rotate it based on that point, an angle of 5 degrees, and hit enter. When we come over here to the back, I again want a 5 degree or a 0.5 line. So I'm going to hit tab, 0.5, but before I hit enter, I'm going to tab again, and I'm going to put 95 degrees here. Now, as soon as we enter that value, I can actually jump back and forth between 5 degrees in the positive direction and 5 degrees in the negative direction. Plasticity doesn't really care. So that can be a kind of handy thing. And then once we're happy, just left click to accept that, and you can keep sketching another line, or we can right click to confirm and be done with it. So those are two ways in which we can get to sort of the same end result, that small 5 degree taper. And now that we have these lines, I actually don't need that anymore. I'm going to delete it. So now we're going to start to build out the rim profile. Now, the way that most rims work is there's going to be a little bit of a lip here. And for some of this, I'm not going to even bother with dimensions. So what we're going to do is I'm going to take that line, that's going to sort of be that extension there, and then we're going to work from down here. Now, a couple of shortcut keys that are handy. Shortcut for the line is Shift and A. You can always come over here and click it, but Shift and A will do that. And also Shift and R will be repeat last command. So that if you are using something that doesn't have a shortcut, or if you don't know it, just Shift and R is a quick way to do it. So with these rims, oftentimes they'll come back a certain amount, and that's going to be sort of that front dish. If you're doing a real-wheel drive car versus a front wheel drive, then the front wheel drive will be much less of a dish because the mounting flange needs to account for the stub axles and all sorts of stuff that has to happen on the front of them. But the rear wheel drive cars can obviously be a bit deeper. That value right there, roughly 0.9 inches, that's going to be the dish of the rim. And then we're going to have a section that comes down, and this is going to be where our spoke actually attaches. And from here, I'm going to go ahead and pan this over. I'm just going to simply come back and connect to there. I want to draw another line that's sort of mimicking that lip, and probably want it to be a bit smaller. So if you draw a line and you need to make some minor adjustments, just select the vertex at the end, hit G and G again. So that second G is going to allow us to move in screen space, and then right click to confirm. And the reason that we do that, the GG or the SS for scaling, is because that way we don't have to click anything. We can just simply, instead of grabbing this and moving it around, we can just hit GG and then it's linked to the cursor. It doesn't matter where the cursor is on the screen. So we've got these. I'm going to box select everything and hit J to join, which will turn it into one single edge. This vertex here, I'm going to leave sharp, but I do want to round off the rest of it. So I'm going to take this vertex here, hit B on the keyboard. I'm going to round it, do the same thing here, pull it away to round it. And I'm going to select this one, shift select this one here, B, and make sure that we round it. And then I'll add a round here. Here we go. Now we can offset it. So O on the keyboard, and we're going to offset it this way. It's going to be a distance of 0.125. Now you're going to find that if you're dealing with a forged or a cast rim, a lot of times the cross section here is not going to be consistent. There'll be thicker and thinner areas. If you're dealing with one of the barrels or hoops that has been rolled and formed and welded, then it's likely going to be a consistent thickness. But for us, I'm going to say 0.125 and then Shift A, and we're going to sort of cap this off. Do the same thing back here. So Shift A, cap it off, and then join them all together. And the main reason we're joining it is because it makes it a little bit easier over here in the curves section. So now we've just got that one curve. I'm going to double click on it and call it rim profile. So that way we remember what it is. This line is that vertical line that represented our 18-inch, and that's fine. I'm actually going to take this inside one and round it off. This bottom one, again, I'm going to keep that square for now because we're going to attach to it, and that'll make sense a little bit. But if you look at pictures of a TE37 rim, then what's going to end up happening is you're going to see basically a fairly sharp edge right there. The next thing that we're going to do is we're going to start to build out the hub section, and then we'll build out our spoke. So we're going to start with a line at the origin, and I'm going to hit tab and come forward 1 inch. This line is going to just be temporary. We're going to move it around until we get it to the right location. So I'm going to use G on the keyboard, Z, and move it up 1 inch. Now, what this is going to do is it's going to give me a 2-inch opening in the center of this rim, spot for a center cap, the section of a stub axle that needs to stick through, whatever the case is. But that center section is going to be open. The next thing that we want to do is move that line back in the X direction. So I'm going to say G, and in this case, Y, 1 inch, and enter. Now, the main reason for this is I could have drawn that line over here and back, but sometimes it's important to just move things around from the origin. And oftentimes you build in a certain direction and you end up changing your mind. So being able to just move it around to precise locations, it really helps. If you happen to make a mistake, let's say that I accidentally move it here and I forget to undo and it's just not in the right location. One thing we can always do is say G and go freestyle, so F, and just snap that to the origin. And let's go ahead and do freestyle to the origin. Let's do this one more time so we can maybe zoom in a little bit and see it. G, F, from there to the origin. And now that it's at the origin, we can simply hit Z and 1 and enter. And now it's back in that same location. So just remember, using the origin as, well, the origin point is something that can be very handy, especially if you need to start over and move things around. Pretty simple line, of course, it's just a 1 inch line out to the right side, but if it was more complex than that, that would be helpful. So the next thing that we're going to do is add a little bit more detail. So there is going to be a small lip. Generally what ends up happening is these things have a small lip or a recess, and I'm going to tap shift. That's going to enable my intersection line. We're going to come out and we're going to come up a little bit. I don't really care about the numbers here, but this will be a small flat section before we transition to an arc. Now, remember when we did that front view with the TE37 image, we had a 5.75 inch circle, and that represented the transition from the spoke to the center dish area. So I need to build that line. I need to figure out how deep it's going to be and where it needs to be. So what I'm going to do is I'm going to make a 1 inch line. So tab, 1 inch, enter. So basically I want a 1 inch dish between that original line I created and this line here. But I need to move it up. So G, Z, and we're going to move it 5.75 divided by 2 to get our radius value. So if you're working with numbers and you don't exactly know what the actual number is, the half, then you can just divide it directly in the dialog box, and that's a great way to do it. So now that we have it here, I'm going to hold down the left mouse button on my circle, go down to a tangent arc, and I want a tangent from this line and end at that point. Now I don't even need this line anymore. I'm going to delete it. So basically what we did was we connected a tangent arc to that point, and it's out in space. And now we're going to build the spoke that comes down to that point. Before I do that, I'm going to join these together, again, just keeping things a little cleaner. Now, the way that the TE37s work, generally they have an arc or some sort of rounded section where it meets the rim. How much it's arced and how flat the outside section is depends on the offset, the diameter, some other specs of the rim. But what we're going to do is we're going to take a line and we're going to build out the spoke that we want to the location we want, and then we'll do a tangent arc from it. So left click, then we'll go to our tangent arc. So from here, I don't want to snap to this point. I want it to come back a little bit. When you look at a TE37, then you actually end up seeing that there is a large fillet that blends this corner between the spoke and the rest of the rim. And if you put it all the way into the corner or you match some other geometry, oftentimes it's not going to give you the result that you need. So I just like it to end a little bit short, and that'll help with that transition. The next thing that we want is to build out the back spoke. So instead of using a tangent arc, we could use just a 3-point arc. But what I want to do is I want to build out the rest of the hub first. So the hub is going to come up. We can come up to a certain distance. So I'm going to say tab. I'm going to do 2.75. Now, if we just hit enter, it's going to accept the line, and we don't want that. So we're going to hit shift, hold down shift and hit enter. And then that will allow us to continue to build this line. Left click to accept. And then we can build out this spoke. So it's going to come forward. I'm going to come forward to the vertical line. It's y-axis in this view. And then come up to where I want the spoke to be. It's going to get a little bit narrower here, maybe right there. Right click to accept. And then we'll do a tangent arc from here to there. Now, this section here is not tangent. It's only adding tangency here. That doesn't really matter for what we're doing, but if you need to have tangency there, then you need to take a little bit more time and play around with it. But this is basically the profile, the cross-section of the spoke and the cross-section of the rim. So I'm going to box select these, hit J to join them together. Without the rim profile, that's not going to work. It doesn't matter that they're not all joined together to actually get a profile. But for our purposes, I just want to make sure that we have two separate sections. We've got the rim profile and the line. So to make this a bit easier, I am going to go to my face selections. I'm going to grab this, go to revolve, and pick 2 points on the y-axis. I'm going to hide that revolve for now. I want to pick this profile and do the same thing. So again, 2 points on the y-axis, right click, and now we've got our rim and we've got the spoke section. Now at this stage, we want to go back to select all. You can do that with either tab or 5 on the numbers at the top of your keyboard, and 1 to go to a front view. So we don't really need to see the rim at this point. All we really need to see is the spokes. So we're going to select the outside edge. We're going to use Alt and D. Now it's alternate duplicate. If you're on a Mac, you can always hit F and you can find. So it's probably going to be Option D on the Mac. Just keep in mind it's alternate or alternative duplicate. I always say alternate duplicate. And basically what we're doing here, and we're going to grab this one as well and do the same thing, Alt D. But basically what we're doing is we're taking those edges and we're projecting them back to our front plane. In this case, this is the default front plane. So now I've got those references. This inside one I don't need, but when we look at an image of the TE37, we basically want to make sure that our spokes are not coming down that far. That can be something, if you don't have that reference edge there, it can be something that's kind of tricky to do. So now at this part, we're going to start with a line from the origin, straight up, right click to accept, and we're going to rotate it. So R on the keyboard, V to set the pivot point at the origin, and then start rotating this over. This is going to have 6 spokes, so I'm going to do 360 degrees divided by 12. Now, the reason for that is because we're building the right half of it, and it's going to be mirrored to the other side. This is the center of the spoke, however. Now, with some rims, you might find that the spokes point down to the center of the circle. With the TE37, they're actually parallel, so we need to offset this. So O on the keyboard. As we begin to pull this out, notice that tab down here says lock distances, but if I hit tab, it actually will offset it in both directions. Now, most TE37s are roughly 2-inch wide spokes. For our purposes, we'll put 1 inch, which is going to be center distance to one of those offset lines, and then we'll hit enter. I'm going to delete the center line. I actually don't need this one either. And I want to zoom in and use T on the keyboard to trim that little section there and hit escape. Then take this line and mirror it about X. Then T on the keyboard again, we'll get rid of these sections in here. Then we're going to join these two together, J. And then B to add a fillet or a chamfer. Now, the first thing I want to do, again, many variations of this rim, I'm going to create a flat spot. Right click to accept, hit B again, and now I'm going to round out those corners. And with that, I can create a radial array. So start at the origin. Remember, it's going to have 6, so drag that to the right. And we should see essentially what looks like the TE37 shape. So if I bring the image back, it's pretty spot on. So it looks pretty good. Now I want to use trim again, just clean this up. I should mention that there are a couple of schools of thought, different ways that you can build rims. And in this case, let's delete that, don't need it. In this case, what I'm doing is I'm building out the entire section, and we're going to use the intersect option when we extrude it. You could build out a single spoke if you wanted to. You could cut away. Instead of using intersect, you could simply remove material, but I find that this works pretty well. So I'm going to join these together. I don't really need to do that, but in this case, I like to do it. Pull this forward. We're going to show that spoke. Notice that there is some overlap in the back, so I want to take the back side, back that direction, Shift and E, and then select the revolve spoke section. So basically what intersect is going to do, it's going to take the solid extrude that we just created, and wherever it overlaps that other revolved surface, it's going to basically create that for us. So right click to accept, and then we can hide that edge curve. You'll notice on the backside that this looks like we maybe made the backside a little big of that profile. Not really a big deal. If you want to, you can play around and resize this. I don't think it's a big deal for what we're doing, but if you need to, you can also go back because we did save the profiles. So we do have the profile of the spoke section. You could very easily make a quick variation of this. So for example, this section here, this line, I would take this vertex and this vertex, GZ, and move it down. But be aware that the tangency between these two is not going to be maintained. So if you have to fix that, what you would want to do is select this curve. You would want to do Alt and J to unjoin. And then we would basically recreate this curve right here. And then if we want to, we can join everything back together. And it looks, for some reason, it doesn't look like it's considering it a profile, but let's join it back together, and now we've got a profile. So again, if you wanted to, you could revolve this, and we'll just do a second variation of this so we can see. Hide that, bring this one back, and extrude it forward, extrude it backward, Shift and E, right click, And now we've got a second variation. So now the hub looks a little bit smaller. It fits inside of that. Whereas this one, this one here, it had that sort of bulky section. So you can, obviously you can decide whatever you want for the profile to look like, but keep in mind, as long as we kept those curves, we can always go back and play around with them. So what I'm going to do is I'm going to delete that first version and I'm going to keep the second version because I like that one a little bit better. And there's not too much left to do on this, but we have a couple more things that we still need to tackle. We need to tackle the lug holes. We need to tackle blending some things together and all those little final details. Now, as I mentioned, we could have tapered these inside faces. We can also rotate them or scale them if we want to. That can be done a couple of different ways. Probably the easiest way is to actually go back and draft those faces. But for our purposes, I don't want to get too far down in these little details. But what I'm going to do is select this back face, hit spacebar, which creates a temporary construction plane, Shift and C for my circle tool, tab 4.5 inches, Shift and C again. I'm going to create a circle here. This is going to be a metric value, so I'm going to use 19 and put mm after it for millimeters and hit enter, and then delete the circle because I don't need it. So the reason for that is because a lot of spokes are going to be, or at least the threads for, not spokes, sorry, the threads for the lugs are going to be metric. So sometimes you may want to enter a metric value. We're going to get off our temporary construction plane, and a couple of schools of thought here. What we could do is we could turn this into a solid body, and then we can build out the rest of the details that we need. And what I mean by that is, let's go ahead and let's hide this temporarily. I can do, let's see, we could do an offset on this face. So what I'm going to do is Control R, hit Tab, and then we could take this section and extend it out. I'm going to bring back our rim section and kind of see where that falls. And what this allows us to do is it allows us to move this entire thing into the right location. So G, Y, and basically what we're doing is we're building a tool that can be removed. Now when we do this, it's a good idea for us to pattern it. So we'll do a radial array. We're going to pick a center location, and then we'll select the rim, Q. We're going to do a difference, which is W, and then Shift select each one of these to remove them. Now the other way that we could do this is just simply taking the circle and extruding it out. I don't really need the circle anymore, but that's one good way we can do it. And also note that I did 6 lugs instead of 5, not a big deal. Obviously we could go back and undo and fix that. So Control Z, back to when we had this, and with that body selected, radial array, pick our center location and just change that to 5, and then do the same thing. Q, W, hold down Shift, right click and accept. So undo is a quick way to just go back a step so we don't have to do too much extra work. And after we've created the geometry, if you want to make any changes, remember we are direct modeling. So we could say take out 1/4 inch of this back face for changing the back spacing of the rim. Pretty easy to do. So at this stage, let's combine these together. So select the rim, Q, hit Q again, which is going to be a union, right click, and now they're joined together. Now we want to start to blend things together. So we're going to select an edge and begin rounding it. It's going to be a fairly big fillet. I'm going to set it at 1 inch. And then I want to hold down Control, not Q, and select the others. So work my way around. Let's go ahead and bring that up. That one and that one. So after I have those, I'm going to right click to accept and then take this one on the side till it looks about right. Hold down Control. And with X-ray on, it can be kind of difficult. So if you need to turn X-ray off, you can just toggle it off here. I don't generally like to use shortcut keys like Alt and Z while I'm in the middle of another operation like a fillet, but you can certainly try it. It may or may not work. Let's just rotate this around. So obviously with X-ray off, it takes a bit more rotating to get back to seeing all those edges, but it's not that bad with only 6 spokes. All right, right click, and we're going to add maybe a small fillet here. And it looks like a chamfer. Let's make it a little bit smaller. And hold down Control and select each one of these and just kind of round these out. These don't have a very large fillet on them. It's very minor, but it does make a difference, especially when we start to talk about renders. Right click. I'm going to round these off. Actually, that one I don't want. So when we want to deselect an edge, we have to hold down Control. Shift will let you add to a selection, but Control lets you remove it. And there we go. That's pretty much it. We've now made a TE37, roughly, in Plasticity. So from here, I like to go to perspective mode, so 5 on the numpad. Come up here, turn my edges off, play around with some of the different matte caps, and just kind of see what it looks like. Maybe toggle off the axes. And I think it looks pretty good. It looks pretty accurate. From here, you can play around with adding as much detail as you want. But that is the basic process where we're taking a look at modeling something that is numerically accurate, because we did start with a true 18 by 8 section. We used dimensions as our input. And then we also were pretty precise with things like the bolt circles, the locations of those, and the pattern and all that stuff. We can do that on the fly with Plasticity, but just keep in mind that there is no true parametric sort of relationship between the curves that we create. Once the geometry is created, it doesn't care what you do with those curves. Delete them, move them, scale them, make other variations. So it's really quick workflow, but it is something that you do need to be prepared for if you are trying to model things that are precise or accurate. At this stage, if you have any questions, please leave a comment. I know we cover a lot on this channel, Plasticity and Fusion mostly, but we do put out quite a bit of videos. If there's something that you do want to see in Plasticity or something else, please leave a comment for that as well. We have a long list, but we do try to get to answer everybody's questions in one way or another. As always, thanks for watching, and we'll see you in the next one.